this video I'll be showing you how I made this spindle sander.
A plain spindle sander would be easy enough to build. In the past I've just used a drum and the drill press, but the reciprocating motion made building this machine more of a challenge. I started off by making the rods the motor slides on. As the drill bits got bigger, I had to lower the RPM of the drill. By looking at the chips you can get a general idea of how fast you're going. You want to aim for the nice curly chips at the top and try and avoid getting them wavy scratchy ones at the bottom. The two 8mm ones are for the rods and the big one in the middle is for the spindle. I couldn't find a drill bit big enough for the middle at a reasonable price, so I decided to try using a hole saw. I had my doubts, but it worked great. For the rods the motor slides on, 16mm steel bar was turned down to 8mm on one end. I'm using a lathe for the convenience, but there's nothing in this machine that you couldn't build without one. For this part you could just drill the ends of the bars and tap them for some threaded rod. Then the bar was partially threaded. The bars were turned to the same length and a small spike was left on the tip. This would be used for locating holes later. When hacksawing thick items it's best not to go wild like this, trying to cut through the part as fast as possible. You'll quickly wear yourself out. It's better to hold your arms tight to your body and rock your legs. I was able to cut a full 15 minutes with no breaks this way. Still can't resist going wild for that last bit though. Next up were the motor mounts. I'm using the motor from a cheap 600-watt tile saw. I've been using Matthias's big print program a fair bit lately. It's cheap and saves me the hassle of laying out. The top mount needs a recessed area to fit the motor. I'm cutting out an MDF jig for the router bushing to follow. I found the bare wood didn't slide very well on the steel, so I decided to make some brass bushings on the lathe. Bushings can be bought ready made, but I didn't want to wait for delivery. These were pressed fit into undersized holes. The lower mounts are held on with a big Jubilee clip. Those spikes on the end of the bars were then used to locate the lower mount holes. The whole assembly could be sort of jammed together, but it definitely didn't slide. With the nuts loosened and the top mount pushed to the bottom, the two rods splay out by about 2mm. This suggested to me that the bushings weren't quite in parallel. The holes were both partially enlarged, leaving about 4mm of the original hole. This allowed the bushings to rock a bit in the top. Shims and fiddling with the screws and the discs then allowed for a bit of adjustment to get things aligned. Also I made the lower mounts. These can be shimmed and trimmed against the motor to get them to align. And that's the motor mounts. The spindle doesn't need to be perfectly accurate since the drums can be true to the table, but a wobbly spindle can lead to a lot of vibrations. I used the lathe to bore the holes for attaching the spindle to the motor. But after that there was a good amount of wobble on the spindle, I'd guess over 2mm. The motor spindle showed was out by about 0.04mm, which is a tiny amount, but over a 250mm bar it adds up to about 1mm of wobble. I still didn't account for all of it though, so I checked my 4-jaw chuck and found that the casting had warped and it wasn't holding the bar parallel to the lathe. To true the motor shoulder I had to go grinding it. I managed to reduce its run out to about 0.01mm. For the spindle I bought steady rest for the lathe, which let me adjust the spindle parallel to the lathe's bed. The wobble was reduced to about 0.72mm, but I still wasn't satisfied with it. So measuring the lean with a dial indicator, I then marked which side needed tweaking and scraped the main face of the spindle with a scraper made from high-speed steel tool blank. I got the wobble down to 0.2mm, which reduced the vibrations to a satisfactory degree, so I left it at that. The frame is constructed from spruce 2x4 and plywood. I'm going to need a smaller amount of reasonably square spruce for these 3 bits. A 2x4 screwed onto a flat board with 3 nuts underneath, 2 on one side and 1 on the other. If it was screwed straight to the table it would twist flat, then regain the original twist when removed. The sled rides on the two angle iron rails and the router cuts the surface of the board flat. The board is then flipped, this time without the nuts, and the other end is plain parallel to the first edge. I then cut a strip off the side of the board to square that edge. I'm transferring holes to the square 2x4. A little bit of wax really makes a hell of a difference in how easily the screws go in. For the sides I'm using some nice birch ply. It seems a bit wasteful since it's so expensive, but it's all I had on hand. The fun thing about designing stuff in CAD is that you never get a good feel for how big it is until you start assembling it. I was really surprised by how huge I'd made this thing. These blocks are glued on flush to the front face of the metal lump. Just stick wedges them in as the glue dries. And that's the frame. For the oscillating mechanism, I'm going to be using a car windscreen wiper motor. You can get these cheap from any scrapyard. I wanted a good amount of adjustability on how it oscillates, so I'm going to be building an adjustable crank throw, as well as a tilt and motor mount to move the centre of the oscillation. The slot is drilled in as wide as the flats on a hex nut. Then I'm moving the drill press table, cutting out a steel circle. The steel halves make a T-track for the adjustable crank. I made the motor mount out of some 2mm steel. Got a lifetime supply of the stuff. I made this sheet metal bender ages ago, and this is the first time I ever used it for anything. I then turned up a weird screw to act as a crank pin. And that's the oscillator. For pattern making I needed a table to tilt. I'm using these beastie 5-door hinges to tilt it on. The threaded rod is just screwed into an undersized hole. For the sounding drum I just fit some spruce discs onto the spindle and turned them round. It was supposed to be temporary, but it works so well I don't think I'll change it. Sandpaper was glued on. I also used another router template to make the step for some inserts. Well, the sander more or less fully functions now, so what's left to do is some wiring and some finishing touches. I wanted to do a reasonably safe and neat job of wiring, so I cracked open the power supply to wire mains directly into it. So much for neat, but hopefully it's safe. The smaller switch lets me turn on and off the oscillating. I'm using 4mm plywood to cover up all the internals. With the inside now hidden from dust, I can grease the slides. To get it at a better height, I moved it to the smaller bench. It's heavy but not unmovable. For the dust collection I made this thing that the shop vac connects to. The front of it can screw off so I can take the thing out and allow the table to tilt. And that's the thing working. There's still a few finishing touches to add, such as paint, varnish and maybe a filtered fan to keep the insides cool without getting dust inside. I should also probably try and devise a spindle lock that can operate from the outside, and some extra spindles for different diameters and grits. But I'm happy enough with how it works for now. I've produced a fancy Google Sketchup model of this available for download. See the video description below for a link and more information. Thanks for watching.